Now we will solve some of the problem based on trust. Problem based on trust. Now in the problem, a simply supported truss is given. I am just drawing the simply supported truss which is given in the problem. I am just drawing the various members of the simply supported truss. So this one is the simply supported truss. Here we are applying a force of 4.5 kilonewton. Here we are applying a force of 18 kilonewton. Here we are applying a force of 24 kilonewton. And these are the points A, B, C, D, E, and F. And here there is a simple support. Here also there is a simple support. And this distance is given 12 meter. And the whole distance is given 3 at the rate of 9 meter equals to 27 meters. So this is the given problem, and in which we are interested in force in member FC. So here we are only interested in a force in FC. So definitely we have to use the method of section. But before applying the method of section, or as a part of method of section, first of all we have to find out reaction at the support. So first of all we have to identify the supports. Here there is simple support at A and D. So we know at simple support there will be reaction RA and RD. So now for finding reaction RA and RD, we can apply the condition of equilibrium. Here there is no horizontal force, so directly we are applying the condition based on vertical forces. So algebraic summation of all vertical forces should be zero. This one is the equilibrium condition. So vertical, or we can say that along y direction. So this one is positive y and this one is negative y. So we can say that algebraic summation of all vertical forces or forces along y direction should be zero. So there are forces in y direction RA. RA is acting in upward direction, so positive. Similarly, RD is also acting in upward direction, so positive. Similarly, this 4.5, it is acting in downward, so minus 4.5. This 24 is also acting in downward, so minus 24. And this 18 is also acting in downward direction, so minus 18 is to 0. So now RA plus RD, and if we sum up this thing, then we will get 46.5 equals to 0. So RA plus RD equals to 46.5. So by this way, we can easily get an expression for RA, that RA and RD, that is RA plus RD equals to 46.5. Now apply condition number 2, that is algebraic summation of moments of all the force about A should be 0. So if you see the A point here, at A we are having the force RA. So moment due to RA at A will be 0 because the perpendicular distance is 0. So RA into 0. We are having the force 4.5 kilonewton here. We are having the force of 18 kilonewton here. And this the distance, that is 9. This one distance is also 9. And this one distance is also 9. So moment due to this 18 and 4.5, we can write 18 plus 4.5, and the perpendicular distance is 9 because this distance is 9. So 18 plus 4.5, it's a total force, and perpendicular distance is 9. And if we see our convention, positive is clockwise is positive, anti-clockwise is negative, so it will be positive. Similarly, for this 24 kilonewton, the line of action is passing through point C, and the distance between A to C is 9 plus 9, 18. So the moment At A, due to this 24 is 24 into 18, that is 9 plus 9, and the direction is clockwise, so positive. Due to this RD, we are having the force RD, and perpendicular distance is nothing but 9 plus 9 plus 9 is 27, and the direction of movement, it is in anti-clockwise direction, so negative equals to 0. If we solve this thing, so we are having 202.5 plus 432 equals to 27 RD. So total we are having 27 RD equals to 634.5. So RD will be 634.5 divided by 27. So RD will be 23.5 kilonewton. Of section for solving this problem. So I am again drawing the given truss. This one is the given truss here. And these are the forces, that is 4.5 kilonewton. This is 18 kilonewton. This is 24 kilonewton. And this distance is 12 meter. This is point A. Here support is there. This point B, C, D, E and F, and these distances are 9 meter, 9 meter and 9 meter. So this is the, again I draw the truss diagram. And now we are interested in the member FC. So by method of section, we have to cut the section like that, which will pass through 3 or less than 2 members. So if we cut the section like that, then we can easily solve this problem. So now draw the free body diagram of a smaller part. So this one will be the free body diagram of the smaller part. This is 24 kilonewton. This is the reaction RD. We already know the value of RD. It is nothing but 23.5. Now these are the members we cut with the section. So according to our assumption, we will draw the tensile force, because our assumption is assume all the forces in the members are tensile. So for marking the tensile force, the arrow will be away from joint, away from joint, away from joint, away from joint. So this one is the force F, Fe. This one, yeah, and this one is the force. We can say that, yeah, this one is the force F, Cf. This one is the force F, C, D. So these are the forces we are having right now, and now we are interested only in F, the force in the member Fc. So we are interested only in Fc or Pf. So directly by applying the condition, algebraic condition, the equilibrium condition, that is algebraic summation of all vertical forces should be 0. So that is algebraic summation of all vertical forces should be 0. So here in vertical direction we are having positive and negative. That is positive and negative. So according to our sign convention, we can write 24, it is in negative direction, so minus 24. Then FCF, that is in downward direction, so negative. And RD, that is 23.5, it is in upward direction, so positive. So now I am having minus 0.5 minus FCF equals to 0, minus 0.5 equals to FCF. or we can say that FFC. So the value of CF here, that is zero point 0.5. So we can say that is FFC will be zero point 0.5 kilonewton, and negative sign which is showing the nature will be compressive. So by this way we can easily find out the value of Fc by applying the method of suction. Same problem if we are also interested in force in the member CE, then how we can find out force in the member CE. So again we will apply the same method, that is method of section, but we have to cut the section like that which should be passed through member CE. So now let's cut the section as shown in figure like that. It should pass through 3 or less than 3 members, and now we have to draw the free body diagram, the smaller part. So now again free body diagram of the smaller part. So now we are having this thing here. This is nothing but RD equals to 23.5. We are having 24 kilonewton force also. Now we are having this cut cut member, this cut member, and this cut member. And according to our assumption, we have to show the forces, that is tensile. So away from joint, this joint is F. This force will be Fe. This force will be Ce. This joint is C away from the joint, and this force will be Fc. So this one is the free body diagram for this cut section, and we want this angle theta. So now we can easily see if we extend this thing here, so we will get the point E, and if we extend here, we will get the point B and this thing. So we know this thing is 12 and this whole thing is 9 meter. So now we can easily see the cos theta and the sin theta here. So here that is 12, this one is 9, so this will be the 15 by Pythagoras theorem. It is nothing but square root of 12 square plus 9 square, so we will get 15. So now we can easily say that the cos theta, that is nothing but base upon hypotenuse 9 by 15, and similarly sin theta, that is nothing but perpendicular upon hypotenuse. So by this way we can easily find out value of cos theta and sin theta. Now we are interested only in the value of FCE. So only one unknown is there. So we can directly apply the equilibrium condition based on vertical force, that is algebraic summation of all vertical forces should be 0. So now we are having 24 kilonewton, that is in downward, so it will be minus 24. We are having 23.5, it is in upward, so 23.5. And the component of FCE in vertical direction, that is FCE sin theta, it is in upward, so positive, should be 0. So here I am having 0.5 plus FCE sin theta plus to 0. So FCE plus to 0.5 by sin theta, and if we know the value of sin theta is nothing but 12 by 15, and if we simplify this thing, then we will get FCE equals to 0.63 kilonewton. The sign is coming positive, so it means it is tensile. So by this way we can easily find problem of engineering mechanics, which is asked in GATE aiming 2008. So now we will see the problem of GATE in 2008. Here in this problem, consider a truss PQR as shown in figure. That is the truss given in the problem, that is point P, Q, and this one is R. The Q point is hinge joint, and at R there is a roller support, and here the force F is applied in vertically downward direction. This angle is 45 degree, this angle is 30 degree. Now we have to find out tension in the member QR. We have to find out tension in the member QR or force in the member QR in terms of F. So we have to find out TQR in terms of F. So let's take a joint P. So now we will draw the free body diagram of joint P. We are interested in free body diagram of joint P. So before that we will mark some angle here. Here this angle is 90, this angle is 90, so this angle will be 45 because sum of the three angles will be 180, 45, 45, 90, 90 plus 90, 180. Similarly here we are having the angle 60 degree because 60 plus 30, 90 and 90 plus 90, 180 degree. So now we are having the angles. So just draw the free body diagram at the point P. So at F, force is coming, and there are two things here. That is point P, and let's assume the tensile force. So this one is the FPQ, and this one is the FP. So there are two forces, FPQ and FPR, and we know this angle. This one is 45 degree, this one is 60 degree. So now apply the conditions of equilibrium, that is algebraic summation of all horizontal forces should be 0. So according to our sign convention, positive x is positive, negative x is negative, positive y is positive, and negative y is negative. So in x direction we are having the component of FPQ in horizontal direction, that is FPQ sine 45 degree, it is in negative x, so negative. Similarly, the component of FPR in horizontal is FPR sine 60 degree, it is in positive direction, equals to 0. So we are having FPQ sine 45 equals to FPR sine 60 degree. So the FPR will be FPQ sine 45 by sine 60. It will be FPQ sine 45 1 by root 2 sine 60 root 3 by 2. So we will get FPR equals to FPQ into root 2 by root 3. Now apply condition number 2, that is algebraic summation of all vertical forces should be 0. So in vertical downward direction there is F, so that is negative because downward. In downward direction component of FPQ, that is FPQ cos 45 downward negative. Similarly component of FPR in downward direction FPR cos 60 downward negative should be 0. So that is minus F minus FPQ cos 45 in place of FPR we can write FPQ into root 2 by root 3 cos 60 degree equals to 0. Now we will rewrite this equation again, that is minus f minus f pq by root 2 minus f pq root 3 to root 2 to 1 by 2 is to 0. That is nothing but minus f pq by root 2 minus f pq root 2 into root 3 equals to 0. Then we can write minus f equals to f pq root 2. We can take it common. 1 plus 1 by root 3. So minus f equals to 1.55 by root 2 into fpq. So we will get minus 0.896 f equals to fpq. So now we are having the value of force in member PQ in terms of F. It is minus 0.896 F. So now draw the free body diagram of joint Q. And if we draw the free body diagram of joint Q, there will be a reaction here. It will be RQ. Here we are having the force, that is nothing but FQP, and now we are having the other force, that is FQR, and this angle is 45 degree. So here we are having the unknowns RQ also. At hinge support I am showing only the vertical reaction. There will be horizontal reaction, but in that case horizontal reaction will be 0 because all the forces which is applied on the truss is in vertical direction. So I am just showing the vertical reaction at the hinge. So here I am not finding the RQ because I am only interested in the force in QR. So directly if we apply the equilibrium condition based on horizontal direction, we can easily find out the value of FQR. So on applying condition, that is algebraic summation of all horizontal forces should be 0. So in horizontal direction we have FQR, that is in positive direction. Similarly, the component of FQP, that is FQP cos 45 degree, it is again in horizontal direction, positive direction, and summation will be 0. So that is FQR, and we can put the value of FPQ, that is nothing but 0.896 F, and cos 45 will be 1 by root 2. So if we simplify it, we will get the value of 0.633. The unit will be whatever 0.633 F, and it is coming positive, so the nature will be tensile. So by this way we can easily find out the force in member QR, that is nothing but 0.633 F, and nature is tensile.